If I have an object with a force being applied to it, and this object is basically going to go from point A to point B. If the object has the exact same speed at point B, regardless of the path that it takes, then this force is considered conservative. Another way of looking at it is if I have an object at some point A, and it goes through a round trip and ends up back where it started, where the change in kinetic energy is 0, then the force that was being applied to it is conservative. Now that's a little bit more specific because that sort of assumes that the force is a constant. And an example of that would be the gravitational force. If I take an object and I throw it up into the air, when it gets back to this spot right here, in the absence of all other forces, the kinetic energy is the same speed, same mass. The velocity is different, but kinetic energy doesn't care about that. So that would be conservative force. Gravitational force is conservative. This path right here is if we have a spring, because that force is variable. So if I compress it and the thing goes bouncing back and forth, every time it gets back to the same spot, it has the exact same speed, regardless of whether it went there and back or there and then went back a couple times and then back here again. So if that is the only force acting on it, then that's conservative. And it's called conservative because energy is conserved. The other type forces, which is most of them, are non-conservative forces because energy is not conserved. For a conservative force acts on an object, it will transfer within the object or within a system, it'll transfer energy from one form to another. When a non-conservative force acts on an object, it will transfer energy outside of the system or into the system. From inside to outside or outside to inside the system, conservative force will just change the type of energy from one form to another.